Hey everybody, it's welcome back to the channel. Shouldn't be a very long one. I don't want nobody to have to worry about watching paint dry. My opinion about when we work on radios, it takes this long to work on stuff and figure out what in the daylights is going on. So I can either make these things 10-minute videos and take me a day and a half to edit them, or I can just show you what you go through when you work on these things. You know, y'all tell me what y'all'd rather have. You know, I just don't have that much time to throw in editing and all this stuff. You know, if you don't like it, move on. My God. Anyway, enough. Get off my soapbox. Let me show you something. On this little Silvertone, I have just been looking. I have been just exploring to see what in the blazes they have done to this poor radio. So pretty much I've come to the conclusion that probably 50 plus years ago they decided to not have a battery set. They decided that this will become an AC powered set. Sometime between now and 70 years ago, they decided to update this radio. Now, I have not found any documentation on how to retrofit these, okay? So whoever did this was an old radio hand that knew all about these things and could probably do this stuff on the fly. Which that's cool, you know. So basically, I downloaded the schematic, Howard W. Sam schematic, okay? And I printed it out in large form so I could read the values first off, and B, it would be larger and easier to make notes and stuff like this. So let's start here at the power supply. Here is how the battery operated sets worked. And that's how this thing was born. I know this because if we take a look back here, see if I can do this without tearing it up. We have two things right here. Important, the battery thrift, sorry, I shake, my hands shake, I can't help it. The battery thrift switch should be in the left new position when batteries are new. About 1 month after battery use, the switch should be moved to the right. Well, this switch is no longer with us. To the right, you got the battery AC line section, high line, battery. It is also no longer with us, which we kind of figured that though, didn't we? No problem, right? Anyway, all of that mess we looked at just then was this switch right here, this switch right here. Here is the battery thrift switch right here, these two guys right here. Here's said batteries. All of this section right here pretty much does not exist. So here is the rectifier right here, the 35Y4 tube number 6. So here comes your line, comes in, goes in through this filament right here, comes back out, comes all the way around, comes over here to this 457 ohm resistor, which is the canned ohm, which is this guy right here, which actually checked good, believe it or not, even though it's disconnected. Then it goes into R63, which is 100 ohm, which comes back over here, goes through 82 to ground. Well, the canned ohm has been disconnected. I thought originally that it was disconnected because it was bad. However, little did I know at the time it was disconnected because it was not being used. So this circuit here, all the way up to here, is gone. This switch is gone. This switch is gone, and there's a lot of modifications in this radio. I haven't got to every one of them yet. So right now I've remapped it, mapped out a lot of things, and let me see. Let's do the filament. Comes out of the cathode of the rectifier, out of the 35Y4. Okay, here comes your raw B plus. First thing it does is in its original version. Comes down here, circles back around, comes over here through this switch through C7A, 80 microfarad. So if you trace that back around, if this is battery or AC position, it's apparently in the AC position. You switch it in battery, it doesn't need a capacitor. That's the way I read that. Anyway, this capacitor is directly connected to here now. Anyway, the B plus goes into this 16 or 1500 ohm resistor into C7C, which is supposed to be 100 microfarad, whatever that means. You see it. That can't be right. That's got to be 100 microfarad. I just now noticed that. Anyway, it goes there through an 820 ohm resistor to ground. Well, that is where you get the filament voltage to run the filament string. So if you follow this on around through this switch, comes up through this switch here, comes out of 3 of the switch, comes up here, you follow it on up. Let me make sure you can see what I'm doing. Comes up here, goes into the audio amplifier. Pin 1 comes out, comes down, comes back around, comes down here into a 1500 ohm to ground. Let's see, what else does it do? Comes back through here, comes out here, goes, look, 40 microfarad. Alright, if we trace this back up, look at there, goes through another filament. Comes back down, and comes out here, goes down here, comes through here, and I guess it looks like it comes through there. Where it goes from there, I don't know. So apparently the filaments are being split off in parallel here. So almost every bit of this mess has been doctored. So I've been making notes here, and what I did is I made a note on the filament string on how I found it. Here's the AC in right here. One side goes through the switch to ground, or electrical ground. The other side comes straight in to the 35Y4 rectifier, pin 1. Okay, and it is one section of that filament is paralleled with the pilot light, or the on indicator. Anyway, the filament goes out through pin 8, comes over to the 50A5, which is in tube 5's position, comes out, comes down, goes into the 14A7, comes out, goes over to the 14B8, comes in, comes out, comes over here to the 7B7, comes in, comes out, goes over here to the 14B6, comes in and out to ground. So they modified every bit of this filament string. Yeah. So the next thing is I believe that's supposed to be a connection right there. Let me put a dot on it. So now the output comes from the cathode of the 35Y4, comes over here, goes through that candome resistor, the small section, which is this section, if you can see it, this little section here and here. That's that. However, that is open. It measures almost 1 mega ohm. Anyway, the B plus comes out of the rectifier right here, comes into this section right here, supposedly, if that was good, comes over here to C7 Charlie, 100 microfarad, or microfarad as we call it in the South, comes over to this 820 ohm resistor. Okay, so that right there was your filament string. That is what powered the filament. However, to keep the B plus normal, this circuit had to stay in there. But it basically, other than putting a load on this right here, they apparently left it here to leave a load on there. But anyway, going back over here where the output of the rectifier comes up into C7A. This was 80 microfarad. I'm not even sure that's even necessary, to be honest with you. But anyway, let's look at it comes out of the rectifier again on pin 7, comes out, goes is filtered by C7A, 80 microfarad, goes through this 820 ohm resistor, is filtered a second time to C7B, which is a 30 microfarad, and then that goes into a 680 ohm resistor. But then we'll show you a little bit more detail about what's going on there. This is a little bit without the filament string in it, okay? Here we go again. Here's the output of the 35Y4. One side goes through the 1.5K resistor, the candome as I call it, R61A. Comes down here, is filtered by the 100 microfarad C7C, goes through an 820 ohm resistor to ground. And that is the filament supply string, which is not used. Alright, again the B++ or B+, comes out of pin 7 of the rectifier, comes down, filtered by C7A, which is an 80 microfarad, goes through R59, which is 820 ohm resistor, 1 watt, comes in here and is filtered a second time, again that's by C7 Bravo, 30 microfarad, okay? Alright, that test point there, or that point right there, goes over to the audio output stage, B+ for it. And then it also connects to the detector preamps stage. So we can come over here and look. So this output right here comes out of the rectifier tube, goes over here through this, make sure I get the right one. This 820 ohm resistor R59 comes over here to C7B, the 30 microfarad that I showed you, comes up into the audio output stage right here. Also, you'll see right here, it also branches out over to the detector preamp stage right here, the 1LD5. I don't remember what the number actually is, but anyway. And then I noticed as I was poking around in there that what are these two resistors right here that was tied in series? Let me get a little more light there for you guys. This guy right here and this guy right here goes to pin 7 to ground. I was like, what in the world is that? It's a 150 ohm and a 470 ohm. Well, I looked up in my tube manual, and pin 7 was the actual cathode for the 50A5 or 50A7. Is it 50A5? I don't remember now. I don't remember what it was. So, and now that they had to supply a cathode to these tubes, I'm sorry, got you autofill. They had, like this output tube, they had to supply a cathode because with the 1LB4, the filaments were the cathode, which is why all the bypass and stuff and all the extra resistors. But since that was an indirect heated cathode now, they had to supply a cathode. So they used a 150 and a 470 to ground. So that's what I found there. Probably the same thing over here. I haven't looked since I've made this determination here. I didn't think about this. The low voltage filaments like the 1LD5 are indirect heated cathode. I'm sorry, direct heated cathode filaments, which is the same thing. But these are indirect. Is that tube number? I'm sorry, guys. I can't remember nothing. The 50A5. That's a 50A5. So that 50A5 was an indirect heater. So it means the cathode was its own person. In other words, the filament was inside the cathode. So to make that work, he had to add these resistors to the cathode so this would work. And I'm fairly sure the rest of these probably have that too. Haven't went that far yet. So with all that fancy stuff in mind, what else can I report? I've mapped out the B+ right here. That's pretty easy there. So I'm probably just not going to use this filament string circuit here. I can't see without making any difference, especially now since this resistor is open. This really serves no purpose. If you want to load this stuff down, you need to do it on this side here. But anyway, this is the filament circuit. This is the B+ for the stages right here. So, whoever did this 50+ years ago, whoever did this I'd say this was a hack. I'm not talking about a hack and like crappy things, but this is what they did to give that customer an AC powered set to get away from these batteries, which were probably getting expensive at the time and troublesome, and they probably always went dead when you was trying to listen to your favorite program. So this radio has been hacked, if you will, quite extensively. I'm not sure where I want to go with this. This was supposed to be a gift for a friend, you know, throw in some capacitors, maybe a couple of resistors, a tube. But as it stands now, I have two tubes bad. The let's see, the rectifier tube, the 35Y4, is completely open. The filament's completely open, which meant this thing was probably got too much current in it and it burned out. I mean, my gosh, if this is right, y'all, it's a 35Y4, and from what I understand, it went from pin 1 to pin 8 directly to ground. So let's see here, pin 1. Let me see. Yeah, pin 1's filament, and 8. I'm sorry, I messed up. I think I screwed up somewhere. Yeah, they put it in here. I'm sorry. This is how it was battery operated, so I've got this wrong. Yeah, that's all wrong there. Apologize for that. But it's in series now, so I don't know. This may have to have a ballast resistor on it. I don't know what blew it, but the filament is definitely open, which meant it got an overcurrent situation. And all these tubes right here, the 50, so you got 35, 50, and then the 14A7, the B8, 7B7, and all these uses 12.6 volt filaments right here. So I don't know what I want to do with this thing. It's supposed to be friending this to somebody, but it's going to take. I can make it work. I can make it work. I can probably leave it kind of like it is and make it work. It probably worked Lord knows how long. However, I don't know, did it actually work or did it just not work? And I don't know. This has been almost my lifespan ago when this thing was probably modified. So what I'm trying to decide now, do I want to continue messing with this and order $50 worth of parts and a couple of tubes for this thing just to gift it away? Or do I want to just make all these notes, put all that stuff back together, put it on the shelf or storage and wait till another day and grab another radio that should be easier, that's a non-battery set, that should be a lot easier to repair, which I have one in mind. So I guess just let me know, guys, what do you think I should do? I kind of, my mind's kind of made up already, but what do y'all think? That's what I've run into with this set, and I haven't got down to the, like I said a few minutes ago, I hadn't got down to the rest of the tubes in the set to see how the cathode arrangements are those. So, but I don't know. It's a novelty radio. I know I can make it work. It ain't my first rodeo and this kind of stuff, but every time I turn around, there's something different in this thing. It's been hacked extensively. And like I say, apparently this was not a, if there was a mod on this, I hadn't been able to find it. And you know, 70 years ago, I don't know if there's a True Tone manual or not for this, you know, or Silvertone manual for this. Anybody knows, let me know. But I'm thinking I'm just going to kind of put this thing back together, put all the parts in baggies, make my notes, put all the notes inside the cabinet and put it aside and start on another one to something a lot easier. I hate to do that because I knew you guys, some of you guys might be waiting in anticipation to see me bring it back to life, which again, I know I can do. I mean, it's not that hard. You just got to make sure everything's right, and once you get all this stuff put in here, make sure it works right. Don't oscillate like crazy, and all the tubes are okay. Make sure all the circuits have got their proper voltages and all that, which means I may have to redesign or re-engineer part of the circuit and stuff like this. So this might be a later on project. Might be later on this year or into hunting season or something like that. I might just put this one on hiatus. So that's where I'm at with this project, y'all. So thanks for just watching. I hope I didn't go too long. I don't want to bore nobody and make anybody die of old age. So I'm going to go produce this video real quick. I'm probably not even going to edit it. I'm just going to slap some names on the front, dump it, send it, and be on my way. So anyway, thank you guys for watching. Please hit that like and subscribe, and let me know what you think. You know, what should I do with this set, or what would y'all want me to do with it? Of course, I know the answer to that already, but it's nice to have interaction with these things. So anyway, I appreciate every one of you guys, good or bad, and hopefully we can get this thing working again some other time. And I'll find I have a radio at my office that will be a good candidate for repair. It's an RCA AM model that might be able to, if I do it right, I might be able to put Bluetooth in it. That'd be a good little project. So anyway, that's it for this one here, guys. I thank y'all for watching. Thank you very sincerely, and I hope to see you guys again later. Y'all take care. God bless. Bye-bye.